quadratics. And you've already done this in Algebra 2, but we're going to possibly take it a step further. All right, first I want to look at these equations. They're not all quadratics, but I want you to look at it and see if you can tell from the equation alone how many solutions does each equation have. If you're not sure, there's a really easy way to know. What you do is you look at the exponent, the highest exponent. Well, that's just x to the first power. So since that's to the first power, there's only one solution to this guy. This one is x squared. And since x is squared, that means there's two solutions. All right, and the third one is x cubed, which means there's three solutions. Okay, so as you look at a quadratic, it has to have two solutions because it's squared, all right, by the principle. So when we look at these equations on the next slide here, look at these examples. We got to find them. We're going to find the solutions. But you remember, little sidebar, we say zeros, but that's also solutions. That's also known as roots. That's also known as x-intercepts. Okay? So you need to get really okay with that. Zeros, solutions, roots, and x-intercepts are all the same thing. So if I look at example 1, I have two solutions here, or two zeros I need to find. The way I'm going to find them is by factoring. If I don't have a graph, I'm going to factor it. Okay, so I have to multiply to get to 44, add to get to 15, 11 and 4 work really great. So I'm just going to do x plus 4, x plus 11. All right, so I replaced the y with a 0. I factored. Now I'm going to set each factor equal to 0. X plus 11 equal to 0. And then I'm going to solve it. So x is negative 4. X is negative 11. Okay? So you could write your answer like that. You could write them as points, since that's x-intercepts. Either way, you'll see it on your handouts like listed. Like this. Okay? It's all the same. Let's try another one. Okay, replace the y with a 0. And then I'm going to factor it. What two numbers multiply to give me negative 8, but add to give me a positive 2? Well, a positive 4 and a negative 2. So I'm going to do x plus 4, x minus 2. I've factored it. I'm going to set each factor equal to 0. So x is negative 4, x is 2. So my answer is 2, negative 4. Alrighty? Alright, let's keep going. Again, replace the y with 0. Notice two solutions, right? Keep that in mind. So when we multiply, we get 25. When we add, we get negative 10. Well, that's negative 5 and negative 5. So if I factor this, look at that. Both factors are the same thing, so it could be written like this. All right? If I take my x minus 5 and solve it for x, x is 5, right? No questions about that. But I have it twice. So what does that mean? Well, that means it is a double root, and it has a special quality when you graph. It means it's going to bounce. Okay? Bounces off an axis, right off. It won't cross it, it bounces off of it. It can bounce up, it can bounce down, just depends on what the graph's doing. But if you see two factors that are repeated, it's called a double root, and there's still considered two solutions there, even though they are falling at the same place. All right, let's try this last one. Replace y with 0, let's factor. Well, this one, there's not three terms, so maybe there's a greatest common factor I can take out, and there is. I can take an x out. So x and x plus 6. Set each one equal to 0. So x is 0, x plus 6 is 0, x equals negative 6, this one's still 0. So 0 and negative 6 are my two x-intercepts on this one. Okay, now notice, if x was just here, that's just x is 0. Don't get too technical. You don't have to add or subtract anything. It's just x is 0. It has to equal 0 according to the equation. Okay. Now let's try this by graphing. You're going to use the roots of the quadratic to help you write an equation in standard form. All right? So you're going to have to read the graph carefully. Here's your plan. You're going to list the zeros. So let's look at our graph. Here's 0 at negative 1, and here's 1 at 2. So I have negative 1 and 2. Write factors that would yield those zeros. Okay, so I need to think about, okay, x plus something equals 0. It has to be solved to be a 1, negative 1. Now, let me back up for a second. If you look up here where we had x minus 5 equals 0, we solved it and x was positive 5. So if you notice, the sign is just switching here. And that happens with all our factors. X plus 6 down here, when I solved it for 0, it became negative 6. So all that's happening is I'm switching the sign when the factor's created. If it's negative 6 on the graph, then it's positive 6 in the factor. So when I come back here and I see a negative 1 on my graph here, I'm going to switch the sign. So it becomes x plus 1. This is a positive 2, so I'm going to switch the sign, x minus 2. All right? And if you're not sure, take the factor you created, solve it for x, set it equal to 0, and solve it. So if you get what's showing up on the graph, then you have the correct factor. Watch for lead negatives. Well, how do you know if it has a lead negative? It's simply, if it's upside down, it's going to have a lead negative. This one does not, so I don't have to worry about that. The last thing I have to do is distribute and or clean it up using FOIL. Okay, so if I just FOIL this, x squared minus x plus x minus 2, then my equation simplified is negative x minus 2. So I want you to be able to take the graph and generate the equation. Let's try another one. Same plan. List the zeros. Okay, here's a 0, and this is 1, 2, 3, negative 4. And here's one at negative 2. Write the factors that would yield these zeros. Well, this is negative 4, so I need to switch the sign, make it positive 4. Negative 2, switch the sign, make it positive 2. All right, that's done, that's done. Watch for lead negatives. Does this one have a lead negative? Yes, it does, because it's upside down. So I put a negative 1 out front. Distribute using FOIL or however you want to do it, but I'm going to do FOIL first. Okay, I'm going to multiply these two binomials together. So I'm going to leave that negative 1 out there. I've got x squared plus 2x plus 4x plus 8. So that's going to be x squared plus 6x plus 8. Now, to distribute the negative 1 simply means I'm going to change all the signs. It'll be negative x squared minus 6x minus 8. Okay? Let's try another one. Again, list the zeros. Here's one at 0, and 1, 2, 3. Write factors that would yield these zeros. Well, if 0 is my 0, then I just need an x there, because x will equal 0 when I set it equal to 0. And positive 3 in the factor will be a negative 3. Lead negatives? Nope, this one is right side up, so I don't have to worry about a lead negative. So now I just distribute. So this will be x squared minus 3x. And I'm done. How about this one? List the zeros. Well, it's only hitting right here at negative 2. Okay? Write factors that would yield these zeros. Well, if it's negative 2 on the graph, it's going to be positive 2 here. Now, there's supposed to be two solutions, right? It's a quadratic. We know that. But it only is, one is showing up. Only one thing is touching the axis. So remember, that's a double root. So when you come to write the equation, you're going to have one factor, but it's going to be squared. You could write it like x plus 2 times x plus 2, but when we get into other things coming up, you're going to want to write it like this so you can see the multiplicity. And you don't know what that means yet, but you will. So when I go to clean it up and distribute it, I do need to separate them out and do FOIL. All right, now, wait a minute. Did I do a lead negative? I didn't, but should I? Yes, I should look for a lead negative. It's upside down. I should have done that. But I'm going to do it right here. Take that negative 1, I'm going to distribute it through. So always make sure to follow our steps, okay? List the zeros, write factors that would give the zeros, check for a lead negative, and then distribute it and clean it up, all right? That's all there is to write in those equations. Okay, on your own, I want you to try this one. You're going to find those solutions for this quadratic, all right? Factor it, set those factors equal to 0, and solve them for x. Okay, good luck, and we'll see you in class.